Hello friends, welcome back to my channel, and in this video we will solve an interesting problem in signals and systems. It is finding the Fourier transform of a modulated signal and a shifted rectangular signal. Let us solve it step by step. So the problem statement goes like this. We are asked to find the Fourier transform of this signal x of t, which is given by sine pi t times rectangular of t minus half. So let us solve this problem by plotting each of the signal involved here. So first let us plot the signal rect of t, whose plot looks like this. It is a rectangular function from where to where, minus half to plus half, with amplitude of 1. So then let us plot rect of t minus half, which is nothing but the shifted version of the rectangular signal to the right by half unit. So you shift this rectangle to the right by half, you get rect of t minus half. And then we have a sinusoidal signal sine pi t, which is simpler to plot, which looks like this. So this function is 0 at minus 1 and 0 and plus 1, and at half it will be plus 1 and so on. So this is a simple sinusoidal signal. Now let us go back to the Fourier transforms. So we will see, we know that the Fourier transform of a rectangular signal defined by x of t equal to rect of t by 2t, whose plot is like this. It is a rectangular function from minus t to plus t with amplitude 1. So that fellow will have a Fourier transform of 2 sine omega t by omega. So the proof of this you can see, I will paste the link here. So there I have derived this result and you can go through that. But let us look at what we have got. So we have a rectangular function with amplitude 1 from minus t to plus t, and that fellow's Fourier transform would be 2 sine omega capital T by omega. Now what happens if I replace capital T with half? So if we replace capital T with half, we get our rectangular signal which we defined in the previous slide. So which is nothing but rect of t. So that fellow's Fourier transform we get simply by replacing capital T with half. So you get Fourier transform of rect of t would be equal to 2 sine omega by 2 by omega, because you replace this capital T with 1 by 2. Then let us look at the time shifting property, which is defined like this. So if you have a signal x of t with Fourier transform x of j omega, then x of t minus t naught, so that is a shifted version of x of t with a shift of t naught, will have a Fourier transform like this: x of j omega times e power minus j omega t naught. Again I will provide the link for the proof of this result, but again let's go back to what we have got. So we are asked to find out the first step, the Fourier transform of rectangular of t minus half. So let us use this time shifting property, and let's assume that our rect of t is our x of t. So you get rect of t minus half will have what as Fourier transform. Let's assume rect of t minus half, let's call it x1 of t, which we will use this in later slides. So again I repeat, you remember that we have defined rect of t minus half as x1 of t. So that fellow will have what as Fourier transform x1 of j omega, and what is that equal to? That would be equal to 2 sine omega by 2 by omega times e power minus j omega by 2. Why? Because we are using time shifting property. So pay a close attention to this. So here x of t is our rect of t, whose Fourier transform is x of j omega, which is 2 sine omega 2 by omega. Now if you replace t with t minus half, what we get? We get a time shifted version of rectangular signal, and hence we can use time shifting property to get this result. So what is this result? This is x of j omega multiplied with e power minus j omega t naught. So what is t naught for us? It is half. And what is x of j omega? This whole term, 2 sine omega by 2 by omega. So what is the summary? So Fourier transform of rect of t minus half will have is given by 2 sine omega by 2 by omega times e power minus j omega by 2. Okay, then let us look into the frequency shifting property. You will soon understand why we are using this. So what is the frequency shifting property? If you have a signal x of t with Fourier transform x of j omega, then x of t times e power j omega naught t will have x of j times omega minus omega naught as the Fourier transform. Again, the proof of this result, I will give the link. You can look at there to see wow, this is correct. Okay, now let us use this property to find the Fourier transform of this signal. So if you have a signal x1 of t, remember that our x1 of t is rect of t minus of. Okay, so what is the Fourier? How do you find the Fourier transform of x1 of t sine pi t? So by using frequency shifting property, I will tell that in a moment. So we can write sine pi t as what? We can write sine pi t as e power j pi t minus e power minus j pi t by 2j. So expanding that out, you get what? x1 of t times e power j pi t minus x1 of t times e power minus j pi t. Now immediately you can catch that these two signals, okay, first term and second term are looking similar to oh, the signal given here, except that x of t is replaced with x1 of t and omega naught is replaced with pi in the first term, and in second term x of t is replaced with x1 of t and omega naught is replaced with minus pi. Okay, now let us try to find the Fourier transform of this signal. So which one? Our x1 of t times e power j pi t times e power minus j pi t by 2j. Using frequency shifting property, we will get this as the Fourier transform. What is that? x1 of t e power j pi t will have x1 of j omega minus pi, and x1 of t e power minus j pi t will have x1 of j omega plus pi. Why you get plus pi? We already have minus and again we have minus, so you will get minus times minus as plus. So what is the Fourier transform of x1 of t sine pi t? Is nothing but x1 of j times omega minus pi minus x1 of j times omega plus pi by 2j. Now let us summarize what we have to do. So we have to evaluate this whole term, which is nothing but the Fourier transform of the given signal. So we already know that x1 of t is what? As we discussed before, it is rect of t minus half, and for that we already got the Fourier transform given by x1 of j omega, which is equal to 2 sine omega by 2 by omega times e power minus j omega by 2. Now we have to find out these two terms. Let us do that individually. So what is the first term? x1 of j times omega minus pi means what? Wherever there is omega, you have to replace with omega minus pi. So that is what we did here. So here we have omega, replace that with omega minus pi. Here we have omega, replace that with omega minus pi. Here also we have omega, replace that with omega minus pi. So then let us invoke some trigonometric properties. What is that? Sine of omega minus pi by 2 is nothing but minus cos omega by 2. That is easy to see. And also e power minus j times omega minus pi by 2 can be written as cos pi by 2. So you get what? E power plus j pi by 2, which is nothing but cos pi by 2 plus j sin pi by 2, which is same as minus j. So that is why you get minus, the 2 is there, and this minus j comes from e power plus j pi by 2, and sine of omega minus pi by 2 is replaced with cos of omega by 2. So finally you get this as the result. Okay, so let's continue. So we want the second term, which is given by x1 of j omega plus pi. So we repeat the same step. What is that? We have to replace omega with omega plus pi. So you get 2 sine of omega is replaced with omega plus pi by 2 divided by omega replaced with omega plus pi, and here also you have e power minus j times omega replaced with omega plus pi, and again doing the same process. So you will get sine of omega plus by 2 is cos omega by 2. Here you have e power minus j omega by 2 multiplied with e power minus j pi by 2, which is nothing but minus j, and hence you will get x1 of j times omega plus pi to be equal to minus 2j cos omega by 2 divided by omega plus pi and e power minus j omega by 2. Okay, so let's see what happens as the last step. So we have to evaluate this term, right, which is x1 of j omega minus pi minus x1 of j omega minus pi whole divided by 2j. So what happens? So let us substitute what we got before. So first term is nothing but minus 2j cos omega by 2 divided by omega minus pi times e power minus j omega by 2 minus second term would be minus 2j cos omega by 2 by omega plus pi e power minus j omega by 2 by 2j. Now you can easily see that 2j is common in numerator and denominator. That fellow will get cancelled, and in the numerator if you look at the first two terms, what is common? Cos omega by 2 e power minus j omega by 2 is common, and this minus times minus will become plus. So what we will get here? So finally we get cos omega by 2 e power minus j omega by 2 as common. So this minus times minus has plus, and hence you will get 1 by omega plus pi. So this negative term will be there, and hence you will get minus 1 by omega minus pi. So we can further simplify, and you can easily see that, I mean, you take the LCM of these two terms, you will get omega square minus pi square. So you will get minus omega minus pi minus omega minus pi. So omega will get cancelled. Finally you will get minus 2 pi. So final answer would be minus 2 pi times cos omega by 2 e power minus j omega by 2 whole divided by omega square minus pi square. So what is the final result we got? So for the signal x of t is equal to sine pi t times rect of t minus half, whose plot is given by this, we can easily see that that fellow will have a Fourier transform of minus 2 pi times cos omega by 2 e power minus j omega by 2 by omega square minus pi square. Okay, so in this video, what is that we studied? We learned how to apply time shifting and frequency shifting properties of the Fourier transform to solve a problem in step-by-step manner. Okay, I hope this video helps you in understanding the concepts better, and if you have found it useful, so don't forget to like, share and subscribe for more such content. Thank you.